We're going to start this tutorial by working with a real example of data analysis and data processing with Python. We're not going to get into the details yet. The following sections will explain what each one of the tools does and what is the best way to apply them, combine them, and the details of them in general. This is just for you to have a quick and high-level reference of our day-to-day process as data analysts, data managers, data scientists using Python. So the first data set that we're going to use is a CSV file that has this form. You can find it right here under the data directory. The data that we're going to be used is this. I have just transformed it into a spreadsheet so we can pretty much look at it from a more visual perspective. But remember, as we said in the introduction, as data analysts, we're not constantly looking at the data, right? We don't have a constant visual reference. We are more driven by the understanding of the data, right? In the back of our head, we understand what the data looks like, what's the shape of it, and that's what it's conducting our analysis. So the first thing we're going to do is we're going to read this CSV into Python, and you can see how simple it is. Just one line of code gets us the CSV read into Python. We're going to give a quick reference, and this is what the data frame that we have created looks like. Data frame is a special word, is a special data structure that we use in the Pandas tool, and again, we're going to see that in detail in the Pandas part of this tutorial. The data frame is pretty much the CSV representation, but it has a few more enforced things. Like, for example, each column has a strict data type and we will not be able to change it, etc. It's a better way to conduct our analysis. The shape of our data frame tells us how many rows and how many columns we have. So you can imagine that with this amount of rows, it's not so simple to again follow a visual representation of it. It's pretty much infinite scrolling in this point. It's 100,000 rows. But the way we work is by immediately after we load our data, we want to find some sort of reference in the shape and the properties of the data that we're working with. And for that, we're going to do first an info to quickly understand the columns that we're working with. In this case, we have date, which is a datetime field. We have day, month, year, and that are just complementary to the date. We have the customer age, which is an integer, which makes sense, right? Age group, you can see it right here. It's age group, youth, customer gender. We have an idea again of the entire data set. We know the columns we have, but we also know how large it is. And we don't care what's in between. We will be cleaning it probably, but we don't need to actually start looking row per row, right? Just with our very limited eyes. We have a better understanding of the structure of our data in this way. And going one step further, we will also have a better understanding of the statistical properties of this data frame. With the describe method, for all those numeric fields, I can have an idea of the statistical properties of those. So for example, I know that the average age of this data set is 35 years old. I also know that the maximum age, in this case, if this is sales data, is 87 years old. I know the minimum is 17 years old. And again, I can start building, right, my understanding of the statistical properties of it. So in this case, the median of my age is very close to the mean. So this is telling me, all is telling me something, and the same thing is going to happen for each one of the columns that we are using. For example, we have a negative profit here, and we have very large values here. Are these correct? Is maybe this a mistake? Again, it's by having a quick statistical view of our data, we're going to be driving the process of analysis without the need of constantly looking at all the rows that we have. It's a more generalistic overview. So we're going to start with unit cost. Let's see what it looks like, and we're going to do describe only of unit cost, which is pretty much what we had right here. In this line, what we did was for the entire data frame, for the entire data. In this case, we're just focusing in the unit cost column. The mean, the median all fields we know already pretty much from this, and we're gonna quickly plot them. We're gonna use these tools to visualize them, and it's the same tool as Pandas that it's using on top, right? It's using Matplotlib. So the visualization is created with Matplotlib, but we're doing it directly from Pandas. And again, don't worry, this is all explained in the Pandas lessons. So this is unit cost, right? This is the box plot we have just created. We have the whiskers that shows us the first and third quartile, the median, and then we see all the outliers that we have right here. So we see that a product that is around $500 is considered to be an outlier. And the same thing if we do a density plot, right? So this is what it looks like. We're gonna draw two more charts, right? In which we're gonna pretty much point out the mean and the median, right? In the distribution chart. And we're gonna do a quick histogram of the costs of our products. Moving forward, we're going to talk about age groups with the age of a customer, and at any moment we can always do something like sales.head to give a quick reference. We know that the age of the customer is expressed in the actual years old they were, but also they have been categorized with four age groups: seniors, youth, young adults, and adults, right? So we have given categories that were created, right, to better understand these groups, and we do that with value counts. We can quickly get a pie chart out of it, or we could get a bar chart out of it. As you can see right here, we're doing an analysis of our data. We see that adults right here are the largest group for our data, at least. So moving forward, what about a correlation analysis? What is the correlation between some of our properties? We will probably have high correlation, for example, between profit and unit cost, for example, or order quantity. That's kind of expected, but that's all something that we can do right here. This is a matrix, right, of correlation showing in red high correlation, so order quantity and unit cost, or where is profit? Right here. Profit is right here. So we see high correlation with unit, with cost, with profit. No, with profit. Actually, it's the opposite. Blue is high correlation. I'm sorry, the diagonal, which is blue, its correlation is equals 1. So high correlation is blue, and we see that profit has a lot of correlation, positive correlation with unit cost and unit price, and negative correlation is with dark red. So we again can have a quick idea. Let's see, for example, here profit, it has negative correlation with order quantity, which is interesting, right? It's we want to dig deeper into that. Of course, the profit has a high correlation positive with revenue, right? And again, it's just a quick correlation analysis. We can also do a quick scatter plot to analyze the customer age and the revenue, right? To see if there is any correlation there, right? And the same thing for revenue and profit. This is obvious, right? We can quickly draw a diagonal here, right? So there is a lot of linear dependency between these variables. So a few more box plots, in this case, understanding the profit per age group, right? So we can see how the profit will change depending of the customer's age. And a few more box plots, and we're creating this grid of year, customer age, unit cost, etc. for multiple things.